Hi, unfortunately it's me again, and recently I stumbled upon a video where they made a sketch pencil shader kind of like, and I really wanted to recreate that in Unreal Engine. So I thought I'm gonna do a little tutorial on how to recreate this effect. So you have this sketch pencil-y kind of rough sketched feeling with a lot of potential too for you to play around and add some own scratches and own pen marks and all of that. First of all, I want to mention that if you just want to have this effect, you can go to my Patreon and buy the shader from my Patreon. The link is in the description down below. And now that we have that out of the way, I'm quickly going through the material, what we're going to build today. This is all of the material that we are going to build. Don't worry, it looks more intimidating than it is, because this is basically a copy of this up here, and then this is just some goodie, and we don't even need that. That's just playing around. First of all, we are going to create all of the outlines of the world outlines using this one this texture thing right here. We're sampling the left, right, bottom and up pixels for the general outlines. We're doing the same for the normal outlines inside the mesh. We're going to combine them and clamping them using this as a mask and multiply them over our slight Toon-Shader. And in the shadows of the Toon-Shader, we are going to have a texture object, and this texture object is just a crosshatch. I'm zooming in here, this is a crosshatch texture that you can create on Paint. And this is essentially how we are going to create this shader. So let's start from the bottom. Material, new material, crosshatch shader. We're going to open this up, and as we have seen, first of all, let's just post process volume, and you're gonna thank me later. Already go down and set this one to before translucency, so it's not going to jitter anymore. Okay, so to create our outlines, we first of all need our center pixel. So how it's going to work is, I'm just creating a couple of this here. We are sampling this middle pixel, and to average the pixel out so it's not jittering, we are averaging all of the surrounding pixels out and adding them together into one pixel, and have a very precise method of drawing the edge. All right. That's the principle behind drawing an outline. How does this actually work? We are going to get a scene texture right here and have our color. No, we want to edit those scene texture to scene depth. Scene depth. There you go. Let's put it into our emissive color. What this is doing is essentially just giving us the depth of our scene. Let's showcase it right here. Asset F. There you go. Did I do it right? Maybe I gotta save it first. We don't see anything yet because we don't have our value. If you divide it by a value, break node, promote to parameter, and see that, we should have some sort of depth to our scene. Where is an object that is closer by? Yes, that's essentially how it works. You know, that's just a quick showcase. Wow, there's a lot of traffic outside the window. All right, so this is our center pixel that we are going to compare around. Now let's just create the other pixel that I showed you earlier. For that, we want to have the same scene depth. We're gonna multiply and press 2 on the keyboard and click. So we got a 2 vector, and this 2 vector, this is the bottom left, the left pixel, so to say. Texture coordinate. We're gonna add these together. You know what? I don't want to cross it. Add these together perfectly, and have another scene depth, because this is only the size, and now we want to have the color, but we don't need all of the colors. We only need one channel out of the color. Component mask only the red channel. So we have a black and white image. Yes, so essentially we want to do this, copy this 4 times. Want to copy this literally 4 times, once, twice, and 3 times, and we want to add these channels. We want to not add these channels, but change these channels to +1. This one is going to be a 0 and a -1, and this one is going to be a 0 and a 1, representing all of the surrounding pixels to our center pixel right here. Center pixel right here. We're not going to see a lot right now. If we, so let's just try and subtracting them from each other to average all of them out. Subtract all of them. No, in subtractions, their order is important. Oh, we want to mask this one as well. Component mask. There you go. And we only want the red channel. The order is important, which means we are going to put the red mask always on top. I'm always confusing them with additions. When additions, the order in what you add is more or less, you know, non-essential. But in subtractions, there is an order to the chaos, and you really wanna keep that. So the mask input goes onto the B input of all of these subtractions. Right down here, here, and here. Yes. And in the end, we want to add all of them together, so we have a nice average. Average. There you go. A on the keyboard and clicking is an add. Add, add. A on the keyboard, clicking is an add. Add, and another one, add them together, and we have our perfect average. Yes, it's looking great so far. Do we already see something? Yes, we have our outlines. We have our outlines. To control how far those outlines go, what these outlines see and what they don't see, we going to add a multiply right here, and right click for promote to parameter. This one is, well, sort of a world outline sensitivity. All right, we want to put that to about 0.2, so it's not picking up everything, but let's clamp it at 2. Perfect. And then there is a power, which sort of is the thickness, but that's those two go together. But thickness is not really the right term for it. It's not really a thickness, but let's just promote the parameter and put that one to a 1. Let's call it world outline thickness. It makes it more slimmer, so in some sense it is the thickness. Yeah, this is our first node tree, and you can see if we put that to like a 0.01 and probably play with this thickness value, at some point you see that we are getting information inside the mesh as well, which is something that we absolutely want. Let's put that to 0.2, usually works. But if we save this and look at what it's doing right now, we're not really getting any information from inside the mesh. Sort of, but we don't really see the normals like on the chest plate. We only see outlines, which is cool and all, but I want to see some normals as well. We sort of see it, but we don't really have control over it. Oh, by the way, if you want to make those lines thicker, you have to change this one to a 2, a -2 to -2 to, you know, just change those variables. Whereas a 1, just make a 2 out of it, and then it's double the size. You only can go full digits though. No 1.5, 1.2 or 3.2. It has to be full digits. -2, -3, -4 if you want to. That will make those outlines quite a bit thicker. To get our chest plate in here, literally just copy paste this one right here in here, and we want to change all of our nah, you know what? Right here, and we're gonna comment over that, and that's our normal outlines. Perfect. And we're gonna change all of the scene depth. Control select all of the scene depth, and scene depth, and we want to change that to world normal. It's the first thing we want to change. Additionally, we want to change those masks. Now we don't only want the red channel, but normals come in very, very different and beautiful colors, and we want to see all of those beautiful colors. So RGB, so again, control select all of these nodes, and RGB, activate RGB. We are adding them together, which is already a great thing. But since our normals look way strange, yeah, they're colorful components, we want to add something in between here. Add components together. Yes. We have RG and B, which is a 3 vector. So we are going to make a 3 vector out of this. Yes. Now we have our beautiful white outlines, and we are going to name world outline to object outline. Yes. And object outline thickness. Object outline thickness. Coolio. If you hear cars in the background, I'm sorry, I have to have this window open because it is summer and blazingly hot. So either I die or you hear some cars in the background, you decide. We want to add these together. So outlines and other outlines. Let's take a max node. This max node is cool because for each and every pixel, it only takes the brightest one. So if we have on the same pixel value overlaying the world normal with the object normal, it will only take the brightest. So if this one is 0.8 and 1.1, if you just multiply them together, there is some strange stuff going on. However, if you put in a max node, this max node will only take the higher pixel value, which is exactly what we want. And what we additionally want is, that's just a cosmetics. That's just a cosmetic clamp. You can see that our white outlines are already glowing, and we don't want them to glow. We don't want them to be emissive. We just want them to be black or white. So we have our outlines, and we see that we have our cool normals in here already. We see this logo, and we see the breastplates and some sort of this crotch and those ankle things. It's really cool already. If you dig that style, go for it. We're not quite done yet, because now we are going to create, well, this Toon-Shader sort of thing. Well, all of this is the world outlines. There you go. And now we create this Toon-Shader with our crosshatch. Let's first of all create a typical Toon-Shader. Scene, texture, perfect. But this one is going to be our diffuse color. Diffuse color. Yes. What that looks like, it's pretty freaky. There you go. It's just really the flat colors. Like, that's just the color information. Right here, there's no shadowing, no nothing. That's the pure color information. Let's get another scene texture, and this time we get the post-process input 0. This is our default input of what our camera is seeing. And we want to desaturate both of these. Desaturation, and I think we want to divide them together, or, well, not together really, but we want to divide them from each other. That's a correct term, is from each other. There you go, make it a bit more beautiful. And again, clamp the result if we need to. Clamp the result 1 to 0. This just gives us more idea over what is happening. All right, we see that we have a cool black and white image, more or less. So we have a desaturated image which gives us 0, right here to 1 values the sky. That's like a 0.8 or so. Okay, we put in an if condition. So if this image, if every pixel of this image is bigger, let's make this a parameter so we can change it later, has a higher or lower value than our shadow catch, then do something, either A or B. Shadow catch, this is between 0 and 1. We put it on 0.6. That's just, you can play around with that, and we are going to play around with that. But what do we want to do if shadow catch is, the value of shadow catch is above our threshold, or we want to display our diffuse color? So what's going to happen? If it is below our value, we want to display, just to showcase, we want to display our diffuse color multiplied by 0.1. All right, 0.1. There you go. What happens? We already have some sort of Toon-Shader, 0.1, and we can play around with our parameter. You see, we have a certain division. If this original pixel on this ball is darker than 0.48, it is going to display this branch. If it is brighter, it is going to display this branch. That's in principle how all of this works. So now that we have separated our light values from our dark values, we can put in some texture work. Let's make a texture object. Texture object. We need this texture object. And we also need a world aligned texture node. That's what we need. And we connect this texture object into this texture object right here. So what does this do? Well, it sort of projects textures from multiple angles onto our object. So it's not from one angle and displaying a ball right here, but it's projecting the texture from all different sides, which means that if we project a 2D texture, and I showed you the texture earlier, it's going to be this crosshatch texture, which you are just going to load in content, just load in as a usual texture, just drag and drop it in here, and then you look for crosshatch, in my opinion, and you have this texture. Yes, this is going to map it accurately along the normals, along the world normals, to this ball, for instance. On this ball, it looks kind of wonky, but it is a very, very important step. Otherwise, your shadows will look off. If you're looking for other crosshatch textures, just type in crosshatch patterns or something. Pen. Yeah, and then just, do whatever you must to get your desired crosshatch. Maybe, go for this one. If you put in seamless, that's even better, and just get this one maybe. Yeah, you know what to do. You know what to do. I'm going to go with this texture object, and we're going to press 3 on the keyboard, and in here, additionally, we can get vector 3, constant vector 3, which is actually the same. And we add something in here perfect. This one, the lower the value, the more often the texture is repeated. Keep that in mind if you want to. The more often, 70, 70, 70, we're going to put that in the texture size. That's what we're going to do. And we promote to parameter, and this is crosshatch size. Yes, we're going to, no, but this one is going to be exactly 0, and we can change that later on. Projection, transition, contrast is the one that we want to focus on the next. This goes between 0 and 100 or something. This is the projection contrast. I don't want to make a parameter out of it. Essentially, if you have 100 in there, well, how do I say it? it is projecting the texture from different angles, and if there is, for instance, on a round surface, two of those textures are crossing, a 1 would be a very smooth transition between this projection, and 100 would be just a sharp edge. I would say that we're going to be smooth with a 6 projection transition contrast in here. Yes, essentially what we can do now is go in here, and that should solve it. So everything where it is dark right now, did we 0. Let's go with 0.6. All right, where it is dark right now, you have crosshatch. You have this crosshatch texture. Okay, this is what it looks like now. The shadows are going to have this crosshatch texture, and it is, the textures is not stretched terribly, and it's fine. And if we adjust the values a little bit more, then it is going to be more than acceptable. All right, this is our progress so far. We want to combine these, or let's make a cheap contrast and a multiply, just to have some control over our crosshatch texture. This is going to be our crosshatch contrast, and this is our this one, our crosshatch multiplier. This makes the texture darker or brighter depending on what you need. We should set that to 1, or else it is going to be completely dark, and this is what we're going to put into our multiplication. This is we're going to put in our multiplication. Coolio. And now we want to multiply these together. What we see is that what's coming out of here is white and black matte, which is, well, we could go for that, but we're going to multiply these things together, which we probably don't want to have a white black matte, but a black and white matte. Let's just add a multiply. Perfect. And we want to just invert these colors with a 1 minus. 1 minus, and then multiply in here, and this multiplication, this should look strange. We have our outlines back, multiplied over whatever is going on in here. We should save, right? Right, I'm gonna save, and we can see the changes in real time. We have our outlines back, multiplied over our little guy right here. Perfect. What we also see is that the sky is black. We kind of want to have our sky back. So what we're going to do is get the scene depth. All right. We want to have that after the multiplication, I think. Yeah. It's the scene depth, and another if the scene you're having is deeper than, I don't know, let's say like 10,000 Unreal units, then get our white matte. 1 on the keyboard, perfect. Then display a 1, a white value. If not, display a black value. And now we're going to lerp these together, linear, interpolate, and use that as our mask. All right. So whenever we have a white value, then we're going to display this one right here. Perfect. And we're gonna display, this is white, this in the background is black, so we can give it any color we want. We can give it another texture if we want. We can have this be our scene texture, for instance, our post-process 0. If we really want to post-process input 0 color, you know, if you're digging this, then you have your background back. If we save this, then we have our usual background without any compromise. Or in my case, before I had just a plain old white. I wanted it to be white, our sky to just be purely white. How are we looking so far? We are looking great. Essentially our shader is complete. Now I want to add one last node to make it a bit more beautiful. Just a bit more beautiful to have more contrast, and this is a remap value range. Because right now I want this to be more white than it actually is. So I say that our whitest value should be 1, but it should already affect things that are brighter than 0.6. This essentially works the same way as our shadow catch right here. Our input high is 0.6, which means that our high values are now way wider. We can put that to 0.2 for instance and see that it's getting whiter and whiter and whiter and whiter. So the lower this number is, the whiter, the brighter it is going to be. So 0.6 I think I found was quite all right. And now we see that our man is sort of good to go. This concludes our shader in general. This is all we need for our crosshatch shader. I'm gonna save it. Perfect. Where did I save it? Post material crosshatch. Perfect. We are going to make a create material instance and its crosshatch instance, and we want to switch this one out. Why? So we have easier access to our values right now. This double click on the instance, right? And now we have all of these parameters that we can change. We can change. Crosshatch size, for instance. If we lower the number, you see there's more and more crosshatch going on. All right, so if we look closer, if we lower the number, there's more crosshatch going on. Crosshatch contrast will increase, like this texture size, depending on what texture you use. This is going to be more or less beneficial. Oh, see, that's a cool effect going into the negative. You know what? I'm leaving it on the negative because that's quite sick, actually. Perfect. Crosshatch multiplier. Yeah, we can. There you go. Why not? Object outline thickness. We said thickness isn't really doing a lot, right? But we can add more of them. And crosshatch shadow. No, we have object outline thickness, and we should have object outline sensitivity, sort of. You see, you can play around with all of these shaders. Shadow catch. That's an interesting. What defines a dark value, for instance? That's what's going to happen. World outline thickness does the same thing, and world outline scale, those are just values that you can now play with. If you put that into negative, look what happens. All right, this concludes our tutorial on how to build this shader, which is quite shy of 30 minutes, but I think it was a very in-depth tutorial. And again, just to remind you, you can get that from my Patreon or from my website as well. If you have any suggestions on what we should cover next, don't hesitate to let me know, and we are otherwise going to see us in the next video. Have fun and goodbye.